This video is going to be about multiplying polynomials. And one way that I like to think about multiplication is, of course, finding the area of something. So if I think about a numerical array, for example, if I had something that was 2 units tall and I was interested in finding, and then I had a length that was maybe 5 units plus 3 more units, I could either add these 2 units together, the 5 plus 3, and get that this is 2 times 8, or I could find the area of both of these pieces, so this is 10 units and this is 6 units. And either way, I'm going to get a total area of 16 units. So I like to use that way of thinking when I'm thinking about polynomials as well. So here I have a height that is 2x units, and the width is 4x units plus 16 more units. So really I'm multiplying that 4x plus 16. So if I find the area of each of these spaces and then combine them, that will be equivalent to the area of the whole shape. So remember when you're multiplying variables that you're really adding those exponents. So here I've got 2x times 4x, which will give me 8x squared. So when multiplying, those exponents are going to increase. And for this piece over here, I've got a height of 2x and a width of 16. So 2x times 16 is 32x. In other words, I'm taking this initial term and I'm distributing it into the parentheses. 8x squared plus 32x. And so this is my area, if you will, right? I'm not sure what x is, but I could associate a value with x. I could pick a value, and I could verify that those two expressions would have the same result. Now, one of the things that's neat about this model is that I'm not restricted to only having a 1 unit height. So I might have a height here that's x long plus maybe 3 more for my height, and then my width is x plus 15 more for my width. So if I think about what that would look like as a problem, it would be that I have this binomial x plus 3 that I'm multiplying by a binomial x plus 15. And I can also think of this, in order to make it a little easier to think about it, I might want to think of this as 2 separate rectangles. So here I have this first rectangle that's x high. Right? So I'm going to distribute this x through the x plus 15. And then I've got a second rectangle here that is 3 high that's also being distributed across the x plus 15. So if I think about what that looks like, I'm going to take this x value and I'm going to distribute it across the x plus 15 to get the area of this top shape. And then I'm going to add it to the area of this bottom shape. So this is sort of my green rectangle, if you will. And then I'm going to add that to the area of that bottom rectangle, which is going to be this second term, this height of 3, right, that I'm going to distribute across the x plus 15. So I've got 3 over x plus 15. Again, the x plus 15 just being the width of the shape. So when I do, so I've sort of distributed, and now I'm going to distribute again. We call this sometimes double distribution for, I think, clear reasons. So here I'll end up with x times x, or x squared. And here I'll end up with x times 15, or positive 15x. So here you can see x times x is x squared. and x times 15 is positive 15x. Looking at the second area, the second rectangle, I'm going to end up with a positive 3x, right, from this space here, and then a positive 45, 3 times 15, so positive 45. Now, one of the things that it's important to note is that these center terms, so basically this box and this box, are like terms, which means I can combine those terms after multiplying. So that gives me x squared plus 18x plus 45. So either way that I do it, if I write out the distribution as the x times the second parentheses plus the 3 times the second parentheses, or if I create the entire area model, I'm doing the same, I'm following the same logic pattern and I'm following the same problem. Okay. If I take a look at a more complicated problem, maybe I want to do something like x plus 2. Actually, let me change that to a negative sign so we can see how that works. So x minus 2 times, let's make it a trinomial. So let's do x squared minus 3x plus 4. So I could either continue to think of this as an area model, and here instead of so remember that subtracting is the same as adding a negative, so I might think of this as plus negative 2. Okay, so those are my terms for my binomial. And then for my trinomial coming across, I have an x squared region. I'm adding to it a negative 3x region. And I'm adding to that a positive 4 region. Okay. So I can see here that I should end up with 6 terms before I'm combining anything. So I could use the area model to do this, or I could use that distribution method that we talked about earlier. I'm going to do this with the distribution, and then we'll verify using the area model. So remember, this first term needs to be distributed into the entire second parentheses. So the x needs to be multiplied by x squared minus 3x plus 4. And then I need to add that result to the second term being distributed across. So I'm going to add that to the second term. I'm going to be careful here because it's a minus 2, so I need to think of that as adding a negative 2. I'm going to put the negative 2 in parentheses just so that I'm not confused with my signs. And I'm going to distribute that across x squared minus 3x plus 4. Okay. So now if I multiply through a second time to do my double distribution, I'm going to have this first area, which will be x to the third minus 3x squared plus 4x. And then I'm going to be adding that whole thing to this negative 2 times x squared, so that's going to be a negative 2x squared. Negative 2 times negative 3x is going to give me positive 6x, and negative 2 times positive 4 will give me negative 8. Looking back through, I'm going to find some like terms. So I've got 2x squared terms here, and I've got 2 linear terms here that can be combined. So I'm going to come through and combine my like terms. X to the third minus 5x squared plus 10x minus 8. Just to verify using my area model, I'm going to do the same thing. I'm just going to take a look. I'm going to find first the area of this upper rectangle, and then I'm going to add it to the components, the terms in the lower rectangle, and I should get the same terms that I ended up with here. So if I look here, I'm going to have x to the third negative 3x squared, positive 4x, negative 2x squared, positive 6x, and negative 8. And then I can combine my like terms here, so I have x to the third minus 5x squared plus 10x minus 8. And we can see through verification through that other method that I'm going to end up with the same result. I hope that that helps you look at how to multiply polynomials, and there are some practice problems that you will want to try to follow up on these results. Please come to class with questions or solutions. Thanks.